evening, ladies as well as gentlemen. Papa Boris here with some more Human Resource Machine. In this video, we're going to do just one puzzle, the inventory report. This is one that I was stuck on for a good long time, but I'm proud to say, and I don't know why I'm saying this, because like, who really cares? I did actually figure this one out on my own eventually. So it's one that I didn't have to look up an answer to, but it took me a long time. I was able to solve it, but like I couldn't optimize it or beat the size thing for quite a while until after I'd finished many future puzzles. This one was my bugbear. So hopefully I can make this a little bit less of a painful process for you. And if you're here because you tried to solve it on your own and couldn't, there's no shame because it's a super hard one. Okay, so the task is actually quite simple. All you have to do is take a input from the inbox and count how many times it's on the floor. Then you just deliver the count to the outbox. So for a C, there's like 2 C's, so you deliver a 2. For a B, there's 5 B's, so you deliver a 5, etc. So how do you do this? Well, we're going to need a couple of things. First of all, we're going to need a count variable. This is where we keep track of like how many of that letter that we've seen. Then we need an address variable. This is the place we store like where we're currently at on the floor. And then we're also going to need a variable I'm going to call IPT. This is short for input. This is where we store the letter that we've picked up. Okay, so basically, at the start of this process, we do need to give these things values. Things are not assumed to have a value of 0 at the beginning, so I'm going to go ahead and copy this 0 here, copy to the count, and copy to the address. And if you're wondering, Boris, why aren't you just using the 0 as the count or the address? This 0 is extremely important because this 0 tells you when you're done. Like that was what stumped me for a long time. I couldn't realize, well, okay, so I can keep on checking, but how do I know when I have finished? And that was one big breakthrough, is realizing this 0 is what tells you when you're finished. So you don't want to mess with this thing. You need to keep it as an actual 0. And if the designers could have made this puzzle much harder by not having a 0 here and making you figure out that's what you have to do, then you would like basically pick up a letter, subtract it from itself, and then deliver it down as a 0 to produce essentially a spot on the floor where you know the string is over, and then you know how to stop checking. But anyway, the test makers, god damn it, the designers were nice enough just to give us the 0. Now, once we've got it all set up, we take our inbox number or letter and we copy it to our input. And now it's time to start the checking process. So I copy from the address and I subtract what's in the input to see if those are the same. And this is actually a really important thing, is you really need to copy from the address and subtract the input. My other big hurdle here was I was always picking up the input and subtracting the address. The problem is you can't do a letter minus a number, so when I would do the letter minus 0, I would get an error, and it was really difficult to know when I was finished. The key is really that you have to pick it up from the floor first and then subtract the input, because while you're holding the value on the floor in your hands, you can check to see if it is 0. If the number is 0, that means you've reached this spot here. So what you have to do is very simply copy from your current count, outbox it, and go back to the very beginning and set everything up again. But if the number is not 0, then you subtract the value from the input. And at this point, you know, if it's 0, that means that you need to up your count by 1 because you found another thing that matches. And you need to also bump your address by 1 because obviously now you need to check the next item on the floor. And you go back to the beginning, you copy from the floor, check if it's 0, and so on. If the value is not 0, then all you want to do is up the address so that you're checking the next item on the floor. You jump to this place, but you don't want to bump the count by 1 because obviously you haven't actually found a match. So this is 16 steps and this actually should work. So let's take a look. We grab a C, before we do this, we set things up. So we take a 0, put on the count, put on the address, because right now everything's at 0. We grab our C, that's our input. So we copy from the address, we pick up a B. It's not a 0, so we're not done yet. We subtract the C. Nope, they're not the same. So I skip the count bump, I only bump the address. And then I go back to this place. I pick up an A, subtract the C. And it's kind of interesting, you see like A minus C is a -2. So if you subtract 2 letters, you get like the number, which represents like, you know, if the A was treated as a 1 for the first letter of the alphabet and the C was a 3 for the third letter, 1 minus 3 gives us -2. C minus A would give us positive 2. What's weird is you cannot add 2 letters together. You can only subtract 2 letters. I guess that was necessary for these puzzles to work. So we try an X, we subtract the C. No, you know, X is the 24th letter, C is the 3rd, 24 minus 3 is 21. So we still haven't found a C. All right, we subtract a B, or a C from the B, so it's still not a match. All right, so the next letter is a C. It's not a 0, so we're not done yet. We subtract the input that is the C. It's 0, so we found a match. So we bump our count this time, and we bump the address, and then we jump and repeat the process. Now let's fast forward a little bit here. This takes a ridiculous number of steps. Okay, so here we go. On the very final letter. Oh, it's not a match. So we bump the address to 14. And now we copy from the 14th spot on the floor, it says 0, so we're done. So we just take the count, which is 2, we outbox it, and we jump. And the only way this could be messed up is if we don't do like a setup at the beginning. We have to obviously delete this 2 and the 14 to get ready for the next input, and we do, so this is gonna work. Blam, 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 and it just takes several hundred steps to solve this thing. But if it, you know, as long as you're setting it up correctly, once it works for one letter, it's gonna work for all of them. This is kind of the annoying thing, is there's no way to just like fast check. Like imagine like working on this and trying to figure it out, like having to go through all this stuff just to see if you like succeeded at the optimization. All right, so here's our last one. Bump. We find a 0, so we're done. There were 3 X's on the floor. Go back to the beginning. We actually have to do these steps. I don't know if there's a way to not have these steps happen. Oh, maybe if I copied it. Oh, you know what? If I took the inbox and copied it and then set everything up, I'd actually shave a few steps off. Wouldn't matter though. I mean, like, well, clearly this is really not optimal. There's just that one little fix isn't going to change things. So we need to go ahead and optimize this now for speed. Now I'm a little bit embarrassed because I don't know if there's like a proper way to do it. Like I don't know if there's some inefficiency here that I could fix by writing my code better. So basically what I did is called in the programming industry complete bullshit, because basically what I'm going to do here to optimize it for speed is just at the beginning count how many A's, B's, C's, and X's there are, and just check, you know, find out what each letter is, and then deliver the appropriate number. So we're gonna have here our number of A's. We're gonna have our number of B's. Gonna have our number of C's and our number. Good job drawing, Boris. Number of X's. Okay, so let's just do a count here. There are 2 C's, so let's copy from the 0, copy it to the number of C's, and we're gonna go ahead and bump this twice. So now this is 2, which is correct because there's 2 C's here. Now there are 3 X's, so let's copy our 2 that we're currently holding to the X's location, and we're gonna bump it by 1 because now there are 3 X's rather than just 2 C's. So now there's a 2 here and a 3 here, and there are 4 A's, so we're gonna copy our 3 to the number of A's, bump that by 1 to get that to be 4, and you can see where this is going. There are 5 B's, so I copy the 4 to the number of B's, and I'm gonna bump it by 1. So just to show you real quick here, all I'm doing is just establishing the counts. There are 2 C's, 3 X's, 4 A's, and 5 B's. Okay, so that is established how many of each letter there is. Now I am actually going to go ahead and take my first input. Let's go ahead and label my spots. That'll be the place I go to check for B's. This will be the place I go to check for A's. This is my X location. This is my C location. Okay, so what I do is I just check. You know, there's going to be one of each letter, so it doesn't really matter which one I do first. I should probably save that, shouldn't I? Yeah, I need to actually save this. This is my input. So I'm going to save this, because if the first try doesn't work, there's no way to get it back. So, because if I like do like a minus b and get a number, normally you can cancel subtraction with addition to get back your original number, but I can't do the number plus b to get back an a because it's going to be a number plus a letter, which is illegal. So I save my input, okay, and then I copy that and subtract my input, and if it's equal to 0, that means the letter I have is a b, so I need to copy my number of b's, outbox it, and go back to the beginning. Okay, but if it's not a b, then I need to copy an a and subtract the input, and if that's 0, then I copy my number of a's, outbox it, and go back to the beginning. But if it's not an A, then I go ahead and copy a C, and I subtract my input, and if that's 0, then I copy my number of C's, outbox it, and go back to the beginning. Oh god, I'm kind of embarrassed to be posting this because this is like just absolutely terrible. And then we copy the number of x's, or the x, just the x, not the number of x's. Subtract the input. And actually, I don't need to do this. If I'm here, that means I found an x. So because the designers don't give you any letters that don't appear in the grid at all. If that was there, this would be a little bit trickier. But basically, if it's not a b or an a or a c, that means it has to be an x. So in this case, I can just straight up copy from the number of x's, outbox it, and go back to the beginning. Now, unless I mess something up, this should work. So let's see it in action. So again, here at the beginning, we're just establishing our initial values. Okay, now I take an a here, save it as my input. Okay, so I'm copying a b. I then subtract the a. It's not a match, so I'm like, fuck it. Let's just copy an a, subtract the input. Ah, that's a match. Okay, so I copy from my number of a's, and I outbox it. That one's taken care of. We go back to the beginning. Here actually, I don't need to jump all the way back to the beginning. Wow, that was stupid. All right, let's fix this. Yeah, I don't need to jump back to the beginning. I only have to do this setup one time. I just need to jump back to the place where I take a number from the inbox. And this is true for all of my jumps. I never need to do these steps again because these all stay the same. But anyway, you get the idea. So we've already done the A. Let's fast forward through that. Okay, so here's an X. Save X as my input. I try a B. It's not right. I try an A. It's not right. I try a C. It's not right. So it has to be an X. So I deliver the 3. Alright, I get a C as my input. And you can see how this is going to work. I try a B. It's not right. I try an A. It's not right. I try a C. It's perfect, so I'm going to go ahead and grab the number of C's, deliver it. And then we grab the B, and well, it's going to work on the first try because it just happens to be the letter I chose first. Boom, it works. I take the number of B's, and we're done. So I don't know if this is what the designers intended. I'm pretty sure it's not what the designers intended because booyah! 57 steps out of 393. Papa Boris owns this house, but clearly that is not a proper solution by any stretch of the imagination. It defeats the entire purpose of the puzzle, really. So, yeah, probably there's a more optimal way of doing this stuff. I must have just done something suboptimally. And I do think I actually, I can actually move these steps in later. So there's something here that I could have done that I talked about. But anyway, that's the solution. That's how it works. This is the puzzle that, like, you know, I had to, like, spend, like, literally half a week before I could figure it out. But yeah, now it all just seems so easy. Thanks for watching, everybody. Hope you enjoyed that. Please like and or subscribe if and you did. And I'll see you again soon for some more Human Resource Machine. Take care, everybody.